Hello everyone. Welcome to the video on organization of 8086 microprocessor. Today we will be discussing on 8086 microprocessor organization. Let me start this one. The first one, 8086 microprocessor is being organized into two functional units. Two functional units which are being parallelly running to have a speed operation. Processing speed is increased by having the parallel processing of two units. One is the bus interface unit and the other one is the execution unit. So the work of bus interface unit is to take the data, collect the data from the memory location and feed it to the execution unit for executing the data. To handle this fetching the data from the memory location, bus interface unit is being facilitated with some of the registers like segment registers, instruction pointer, and in addition to that one there is a separate a 6 bytes instruction message. This is the thing which is there for a bus interface unit to collecting a data from the memory location. Once the data has been collected from the memory location, it will be fed to the execution unit. Then again, once the data is being processed or it is being executed, again the data is being taken up and it is being fed to the memory location again by the bus interface unit. So it acts as an interface between the execution unit and the memory. So what the execution unit will be doing? Execution unit will be composed of ALU, some general purpose registers, and when there is an ALU operation, obviously the set of flags to be indicated. That's the reason execution unit is been having one flag register. In addition to this general purpose register, we require some more pointers and index registers. The reason all these registers have been composed and forms an execution unit. And this whole thing is been brought up in an architecture which is shown over here. So this is a total architecture of 8086 microprocessor. You can clearly see in the dotted line is the internal structure of 8086, and when it is in interface to an outside world like memory is in interface, that collects from data is being collected or fed to the memory through the bus interface unit. So this is your instruction to fetch queue, 6 bytes of instruction to fetch queue. You have some segment registers, 4 segment registers are there and 1 instruction pointer register. And this is the execution unit. The execution unit consists of ALU, some flags, and general purpose registers, index, and pointer registers. So we'll list out the registers for bus interface unit and execution unit. Bus interface unit consists of total of 4 registers. One is code segment register, data segment register, stack segment register, extra segment register. All these 4 registers are specified to give the starting address of each of the memory segments. Usually in 8086 microprocessor, it can interface up to 1 MB of memory. That 1 MB of memory won't be working at a time. We will be working with clusters of 64 KB. So these 64 KB clusters are being given with a starting address in the segment registers. Like the code segment is given by the code segment register, data segment is given by the data segment. And one more register which is very important when we go for the executing of the program, which is the program of codes are stored in the code segment. So the register which is used as a pointer in the code segment in the instruction pointer. So this register along with the other segment registers are in the bus interface. This will be very much required in the time of collecting a data from the memory. The next part is about the execution unit. What execution unit consists of? Execution unit consists of 4 general purpose registers, 16-bit. All these are 16-bit registers. AX, BX, CX, DX. All these are 16-bit general purpose registers. In in addition to these 4 general purpose registers, you had a stack pointer, base pointer, source index register, and destination index register. Now, these general purpose registers, the AX register is also called as an accumulator. It's mean to say it is specified with a certain set of additional functionality other than the general addition and subtraction or general purpose operation. And similarly, CX is also given the responsibility or the work of count in the microprocessor. Likewise, DX is used for the IO ports addressing. These 16-bit AX, BX, CX, and DX can be used as 8-bit registers also by naming as AL and AH, BL and BH, CL and CH, DL and DH. Now, these 2 registers, the pointers, usually this stack pointer is strictly confined to the pointer in the stack segment. This is being located in the execution unit because the stack pointer has to be initialized in the programming. That's the reason it is being indicated over here. Similarly, the base pointer is there, which is used as a pointer for any programming usually required. And this source index and destination index are usually used to point out in the data segment and extra segment, pointing out in extra segment and data. When you use the memory locations, usually source index and destination index has been used. So, coming the specific applications of all these general purpose registers, accumulator, AX is an accumulator for 16-bit, and you can have 8-bit accumulator as A. CX, now I told you, it is an account register. When it is used in loop counter, automatically the account register would be decremented when you go for the execution of loop. Data register or DX register is used for I operation. So this is an overview of the total organization of 8086. Thank you, and the next video will be covering about the internal memory segmentation and other things about the organization of 8086.